Hi, I'd like to record a cryptographic engineering, Group 7B, Assignment 2, Lab 1. So, this is per assignment Song Ching Wing, matric number MEC 244038, Khaled Hussein Ahmed, MEC 244029. Outline of the presentation. So, this is consists of two parts, part A and part B. And this is lab environment and tools. So part A is encryption and decryption by a binary ciphertext. So we create plain TXT. We contain full names for the per student and the student ID as well. So we use an open SSL command as well, encrypted plain text to the binary file. And also we provided the ciphertext by displaying in a binary format using XXD, and decrypt the ciphertext to the file name decrypt.txt. Then we screenshot the command consisting of a step A2 to A4 using same plain text file reduced to the step A2 to A4 for producing a ciphertext in hexadecimal. Then verify the decrypted message matches to the original plain text. Let us come in part B, where it is decryption happens by the binary ciphertext. So we decrypt the ciphertext 7b.pin into file name ciphertext 7b txt. Shows the decrypted message of the binary file and the decrypted message in cipher 7b.pin.
Hello everyone, my name is So Kian Wei. Today I will be presenting the encryption and decryption using OpenSSL on Kali Linux. We will demonstrate how to perform encryption and decryption directly through the terminal using the commands that everyone can apply in daily work. Thank you for your attention and let's get started. Okay, let's begin with changing the directory path to the place we want. I already have the path here. So this is the path. I have one file here, ciphertext7b.bin file. Okay, let's begin with by generating the key. First, we're going to convert the text file into a file called aes_key.text. So it contains of two lines. First, I echo the first line, and then by echoing the second line, I do the double arrow here to append it to the aes_key.txt file. So we can view this file by using the command cat here. This is the key given, but this is in the ASCII form, in the text form. The next thing we're going to do is we're going to convert this into AS key. And the command used here is tr-d by removing the next line, the row break, and the empty space into the aes.key file. Okay. Now we already have the aes.key file generated ready here. This is the key file. And we can make use of the XXD with the hexdump command to confirm this file is this aes.key is in the hexadecimal format that we expected. Alright, once we have the key ready, we can proceed. Let me clear the screen. And first, for the A1, we're going to create plain text with the content of student ID, my ID, and my name here. Okay. Once we've done that, next thing, we're going to encrypt this into output file. This parameter dash out is the output file, dash in is the input file, plaintext.txt we created here. And then by passing in the key, we're not using password, we are using the key to encrypt and decrypt. This is a symmetric encryption and decryption. Okay, this is successful, and we can check by SD command to see how's the encrypted file looks like. This is the bin file we generated. Next, just a very similar command is used. This time we're passing in the ciphertext.bin and outputting the file decrypted.txt file with the same AES key. Okay, and we can take a look at the decrypted txt file here. It is the same content as what we're passing in into the plain text. To confirm that, we can use cat command on the plain text as well, so we can compare the decrypted file and the original plain text is the same. Furthermore, we can use the diff command to check the plain text and the decrypted txt. They are the same. Okay. Now we're going to clear the screen and see with the next steps. Next one is the same plain text we're going to use back, but this round we're going to encrypt it in the hexadecimal format. Okay. Under this format, we can view. So now we output the file to the encrypted.hex file. In order to view this hex file using fxd command, we need to pass in the -p parameter, and this is the hex format of the file. Now we can proceed with it. So here we pass in the -d for the decryption, and using the same key, output to the decrypted.hex. And to view the output, we can select decrypted.hex, and the content is the same. It's the same as the plain text. Okay, and we're going to clear it and moving forward to the last part. The 7b.bin file we got for this group project. Okay, this file is obviously encrypted. In order to decrypt it, we use back this very similar command. At this time, set decrypt in and this same AES key, we need to add in the -sort parameter because this file is sorted. And then we're passing in this as an input file, ciphertext 7b.bin as input, and we output the ciphertext 7b.txt as output. Okay, here we see a warning message because we didn't use the new parameter -pd_kd_f2. It is okay to ignore it. All right, now we can take a look at the ciphertext 7b that we have decrypted, and this is the message we got. Thank you.
Decrypted message in a ciphertext 7b.bin, group 7b. To safeguard data is a critical component for today's digital landscape, ensuring the security of both personal and corporate information. Encryption transforms the plain text into coded form. So, to protect it from unauthorized access, by applying cryptographic key and algorithms, it ensures that even if the data intercepted cannot be understood because of the way it's encrypted. This exercise demonstrated us how the encryption contributes to the maintaining the data privacy and the security. And this is at the end of our group assignment, Lab 1. That's all from us, So Ching Wing and Kairat Hussein Ahmed.